Hello, everyone. This is Julieta, and on behalf of AppOmni and 451 Research, which is now part of S&P Global Market Intelligence, I would like to welcome you and say thank you for attending today's podcast titled Locking Down SaaS Risk with SaaS Security Management. Before we start, I just want to share a quick few housekeeping items. To ask a question, simply type in the question on the question box in your screen, and we will get us to as many ones as we can. The presentation slides are available for download in the resources section on your screen. And also, finally, please check back for the on-demand version of this webinar, which will be available briefly after the conclusion of the event. And with that, I will turn it out to the speakers to kick off the conversation.
Hi, good afternoon, everyone. Thanks for joining us. So my name is Garrett Bekker, and see if there we go. Thanks for joining us today. I'm Garrett Bekker, and I'm a principal analyst, excuse me, at 451 Research. I've been here about 8 years, and I cover cloud security. I also cover identity and access management, zero trust, and SASE, and things like that. So before we dive in, just a rough agenda today. I wanted to look at some trends in cloud adoption, particularly for SaaS apps, and also take a look at the broader cloud security market and really try to drive home the point that what's typically called cloud security today is really talking about infrastructure as a service and platform as a service. But we'll see, and we'll certainly talk about today, that security for SaaS apps is a completely different animal and requires its own approaches. We'll also take a look at some of the specific security risks related to SaaS applications and some of the ways to mitigate them. And then I'll turn it over to Brendan, who will look at some of the common pitfalls with respect to SaaS security, some of the takeaways, and some examples and best practices with respect to SaaS security. And specifically, he'll look at things like challenges with third-party applications. I think he's going to take a look at a customer support portal and anonymous API access and things like that. So jumping ahead to, there we go, slide 5. Hopefully you can all see this. This chart shows some data from a service that we call our Voice of the Enterprise. And we survey several hundred senior level IT decision makers on a variety of topics. And this one was about where your current workloads run and where do respondents see their workloads running in the next 2 years. And a couple key points jump out at me here. First, fairly obvious one, cloud adoption is growing and more workloads are moving to the cloud. Nothing too controversial there. It should be pretty straightforward. But I want to call out was a few things specifically. One, more than half of all workloads will run in some form of public cloud in the next 2 years, and specifically 57%. The other point I wanted to make was that really the mirror image of that was the rapid decline in workloads that are going to run on-prem. In fact, that's the orange boxes at the bottom if you can't see that. But it's essentially telling us that workloads are going to be almost fall by 2/3, from 38% to 14% over the next 2 years. The other point I want to make is that the number one venue to run workloads will be as a SaaS application. That will be number one in the next 2 years. So that's a big takeaway, and we'll talk about that a little bit on the next slide. One of the other interesting things for me, though, one of the biggest takeaways is that each of these venues, look how widely distributed they are, right? And that means that essentially they all have different architectures, which in turn implies that they all have different security requirements. And I think there's a lot of tendency to look at all the benefits of cloud, and I certainly get that. But if you think about the average security practitioner who typically runs a hybrid enterprise these days, and unfortunately I don't have any hybrid data slides, but our data shows that most firms are now running in a hybrid environment. What that means is essentially from a security standpoint, you need to secure all of it, right? You still need to deal with your legacy on-prem systems, but you also have to deal with your new cloud environments. So I don't know, Brendan, is anything you want to address? I know we talked yesterday about you'd seen a fairly rapid move for your customers. I don't know if you want to weigh in on that.
I talk to a lot of CIOs. I talk to a lot of CISOs, and I think that, anecdotally, all the data you're showing, I hear it. I hear it in the field because we had to do so much data migration, application migration, and cloud migration in the past 2 years. No one feels like they got it right. No one feels like they got everything perfect. We did what we needed to do on a very accelerated and compressed time frame, but no one feels like they got everything perfect. There's some general unease on what did we not button up, what did we forget about, what did we not consider in our move to the cloud. So I hear it when I talk to customers, and I think that this data shows it.
Excellent. So this next slide basically double clicks on that same point. It's essentially that, SaaS applications are the most widely used form of cloud application these days. And really just to drive that point home, nearly 3/4 of all respondents are now using SaaS apps, which is the number one choice by a wide margin. Number two was infrastructure as a service and platform as a service at 61%. And also maybe worth calling out that that's nearly double the number that are actually using on-prem private cloud. So, this is essentially across every type of business we're seeing this sort of adoption too. And I know, Brendan, did you have anything you want to add to that?
I just think that SaaS security is, clearly the number one form of cloud, but how is something that's this prevalent and this popular still so poorly understood in the enterprise? And I think that speaks to, we don't have a clear shared responsibility model. We don't have clear ownership. And, SaaS doesn't fit cleanly into any of the classical architectures that we're used to working with. So I think it is a little bit of an odd duck, but it's funny that it still is the number one way customers of all sizes consume cloud, but it's the least understood.
Right, 100%. So this next slide, and really the point I wanted to make here, was that cloud security, along with the adoption of cloud security continues to be a top IT pain point. And this has pretty much been the case since I've been covering cloud security over the last few years, so it's certainly nothing new. It's been a primary impediment to broader adoption. And I think you can make the point that while most firms have some degree of cloud services deployed, as we've seen, and I think you can also make the point that most are getting more comfortable putting critical data and sensitive data in the cloud. Security remains the number one organizational concern that they have, and it hasn't dropped as a pain point as cloud adoption has increased. And I think the difference between this slide versus the last two, which is really about looking at how the business side has changed cloud adoption, and certainly business units are moving that way. I think it's fair to say also that security is really becoming more critical to the business, even though cloud security has been fairly steady as a pain point. And I guess one of the things I want to point out is that this slide, like a lot of the studies we see on cloud adoption, really doesn't distinguish between infrastructure as a service and SaaS security service. And I think there's maybe a different reality with SaaS, and I think companies are finally starting to realize the importance of SaaS security as a completely separate entity from the security issues they may see with like AWS or Azure or GCP.
Couldn't agree.
Go ahead, Brendan.
I was going to say, couldn't agree more. Cloud security is a very overloaded term. And the way that you protect your workloads in serverless, or the way that you run virtualization in Azure, or the way that you run SaaS like GitHub, those are very different technologies. And the types of controls and the types of things that you need to worry about are different for each one of those. So cloud security is sort of a catch-all, but with everything being cloud, what does cloud security mean? I think we got get a little bit more specific. Protecting workloads, infrastructure as a service, platform as a service, SaaS, they're distinct areas.
100% agree. So moving to my next slide here. Let's see, where do we go here? Okay, so no surprise then. These two slides look similar, so I got confused for a second. Basically, shifting from top pain points to top security priorities is not a surprise then. Securing cloud environments is number 2 InfoSec project over the next 12 months, according to our survey service. And that's actually ahead of other hot topics in security, things like regulatory compliance, which came in at, where was that number? little bit further down, I think number 5. Zero Trust is another big one that I spend a lot of time on in years. That's further down the bottom. And I should also point out that securing cloud workloads is a high priority, coming in at number 6. So next slide I really want to talk about is how do I view and how do we view the cloud security market from an analyst perspective. And a couple things. First of all, this market is still quite young and still in its infancy, arguably. Again, I've been covering for about 8 years. I think arguably cloud security as a whole has only been around for about 10 years. I think that's point one. The other point I wanted to make is that we've seen tons of financial activity in this space, and perhaps not surprisingly, but over the years we've seen an awful lot of venture capital flow into this space for probably obvious reasons. Certainly the earlier slides would certainly support that. We've also seen a lot of M&A activity in the past few years. But as I hinted at earlier, the cloud security market is really not homogeneous. It's really different ways to slice it and dice it. And really one way that I like to think of it, and this is fairly high level, but you divide it between, there are basically 3 groups of participants in this market, or combatants, if you want to think of it that way. And the obvious one would be just some of the legacy security vendors. Their names like, Palo Alto and Zscaler and Cisco, what have you, are playing a bigger role in cloud. And some of that's been via organic development, but also a lot of that's been by M&A. And in fact, a lot of these vendors have splashed out a lot of cash in the past few years to get involved in cloud security. In fact, I would argue that a lot of them were late to the party. Previous years, I put out a number of reports predicting that the incumbent security vendors were sort of ignoring cloud security, so they finally caught up. And they've been putting out a lot of M&A activity in the area. Also, cloud providers, that's the other big actor. On the IaaS side, it's the hyperscalers like AWS, Azure, and Google Cloud Platform, GCP. And then even on the SaaS side, we've seen some of the large SaaS providers have some pretty extensive investments in security over the years, whether it's Box or Salesforce or Microsoft 365. They too have had a combination of both organic and M&A in terms of development to build up their security strategies. In fact, just this morning, maybe some of you noticed, there was a pretty notable one. Google announced this morning that they're going to be paying $5.4 billion to acquire Mandiant to basically add their incident response capabilities. Lastly, and then we have these standalone third-party cloud security providers. So vendors like AppOmni, which compete in a variety of cloud subcategories that we'll talk about in the next few slides. But certainly it's a thriving ecosystem. I mean, there's at least 100 standalone cloud security providers that we've counted, and that number just seems to keep growing. Brendan, anything to add to that?
I would just call out that the 3 main security vendors that you have listed, the established security class, Cisco, Palo Alto, and Zscaler, these are network security companies. And there's a lot of network security problems. But when you look at SaaS, fundamentally, it's an application and data problem, not a network problem. And I've seen that, when you're a firewall admin, you think a firewall is the answer to everything. But looking at the way SaaS works and the way the multi-tenant model works and the way you have combined database, application, web server, and third-party apps all kind of rolled into one system without clear layers to it, it's not necessarily a network problem. So I think that we have taken previous approaches to try and build a wall around the cloud or extend our LAN-based firewalls to the cloud. And there's certain value in those approaches, but I think overall trying to build a firewall around the cloud is not the way forward. You got to be looking at zero trust. You got to be looking at identity. You got to be looking at securing your data and securing your applications, not just hoping that the bad guys can never get to it.
Yeah, 100% agree. In fact, I started out my career doing network security about 20 years ago, and I was analyzing those markets, and then I was actually installing it. And I think it's a fair point. A lot of people in positions of authority and security now basically cut their teeth on network security earlier on, and a lot of their approach is always buy some box with blinky lights and put it in the rack. And I jokingly said that, they say if you have a hammer, everything looks like a nail, and if you have a firewall, everything looks like a layer 4 IP packet. So 100% agree on that. So moving on to the next slide, here's basically another way to break down the cloud security market, and basically in terms of what they're designed to secure. And essentially the way I do it, and also my colleague John McNeese, who covers the infrastructure side, we basically divide it that way. So on the one hand, you've got security for infrastructure as a service and platform for a service. And then on the other side, you got the SaaS side, which is what I cover. I think there's also another point to make as well, and this is fairly easy. Some people make this mistake, but I'm very careful to distinguish talking about security for SaaS apps as opposed to security delivered by a SaaS model. And certainly we've seen over the years a lot more of that. You see vulnerability scanners and DLP, even firewalls and things delivered in a multi-tenant SaaS architecture. To my mind, that is not SaaS security, although I've seen market forecasts and conversations out there in the media that actually lump that in, but I think that's a completely different part of it. So in any event, very high level. On the right side, we've got some various categories of security for infrastructure as a service. And I think one important point is basically follows the shared responsibility model. Certainly, you could argue that the SaaS side does as well, but there's a lot more sharing of that responsibility on the infrastructure side. Certainly, the cloud provider is responsible for securing things like the underlying infrastructure, the bare metal, hardware, things like that. While customers are generally further up the stack, they have access to and are responsible for everything on top, the middleware, the applications, the data, et cetera. So some of the broader categories that we have under there traditionally was cloud infrastructure security, although that name seems to have gone by the wayside over the years. And we hear more about things like cloud workload protection, which essentially deal with things like threat protection, vulnerability scanning for cloud workloads, et cetera. We've all got cloud security posture management as a new one, or CSPM. And that essentially deals with looking for misconfigurations and improper settings in cloud services. And the classic example that we hear all the time is, basically making sure that your S3 buckets aren't accidentally exposed to the public internet. There's a new category these days called CIEM, Cloud Infrastructure Entitlement Management. And that deals with things like managing permissions and access rights within public cloud environments. And what we typically find is a lot of cloud services will over-permission access rights and entitlements to the extent that a lot of them are unnecessary, but they represent certainly an attack vector. There's another one called CNAPP, which is Cloud Native Application Protection Platform. And that's a new one that I won't spend too much time on because quite frankly, I find that most people are still trying to figure out what it means. But it's got a lot of different things in it, a lot of AppSec tools like dynamic app security testing and web app firewalls and software composition analysis, et cetera. Also lumped in together with cloud workload protection, CSPM, and CIEM. Moving on to the SaaS side, again, SaaS is a completely different animal, and what we find is that the cloud provider controls most of the stack, which is a different challenge than we have on the other side. But we've seen a number of different approaches to securing SaaS apps over the years. Probably the first one was identity as a service, which I cover. And that was companies like Okta and OneLogin who basically figured out a way to do single sign-on for SaaS applications, typically by building things like SAML integrations or leveraging things like OpenID Connect, and they'd build up an app catalog. Next or later came things, I'd call them the cloud encryption gateways. And the idea was, hey, before we put any sensitive data up in a SaaS app, maybe we should encrypt it. So what these products essentially did is they would encrypt traffic between an enterprise and a SaaS provider with the idea of keeping data secure, although what we found in reality, it didn't work that well, and there was a lot of problems with getting the apps to work properly. That category was essentially folded into CASB, which was an acronym for Cloud Access Security Broker. And what they did was essentially started out basically doing discovery. So firms could figure out what SaaS apps were running in their environment, make sure nothing was running that they weren't aware of, and then they would risk score them so they would have an idea of how much risk they presented, whether they should let them run or not, et cetera. And then later they added things like encryption DLP to CASBs. But I'd say right now, the CASB market is essentially, as a standalone, has pretty much gone away, and it's been folded into a new category called SASE, or SASE. And then we've also got SSPM, which is kind of like CSPM, but just for SaaS apps. Last one here is SaaS Security Management, but we'll go over that on the next slide, and I'll let Brendan talk us through that.
Thanks so much, Garrett. I appreciate it. I love to see how this has evolved, and hearing from an experienced analyst like you, you've really been in it for many, many years and seeing this evolution. And quite frankly, many of your predictions have turned out to be spot on over the years. So thank you for walking us through that. I'm going to talk about what is SaaS security management and what those components are. So SaaS security management is holistic SaaS security. SaaS doesn't have just one problem. There isn't a security button. And as long as you turn the security button from off to on, you're secure and everything's locked down. I would say, think of this like an operating system or an endpoint. You can have strong passwords and authentication on your laptop. That doesn't mean that's the only security problem that you have to worry about. You should have strong authentication. You should have a good password policy. But just because you have that doesn't mean you're not at risk of ransomware or a breach or malware taking over that user's credentials or having a malicious application running on the operating system. None of those had to do with passwords. You can have secure passwords and still have those challenges. So when I look at SaaS security management, I want to apply the same level of thinking. Security is a team sport, and it usually comes with a series of layers. It's defense in depth. So number one, you've got your system configuration. What are all the levers, knobs, and switches? Do we have multi-factor authentication enabled? Do we have logging enabled, and do we have the right levels of logging? Have we adopted things like cross-site scripting protection and a lot of the best practices that the cloud providers are urging us to adopt? The second layer is you got to look at permissions and access control. Who are your users? Who are your integration accounts? What service accounts and workers do you have that integrate with other SaaS applications or that integrate with things that you have running in AWS or on-prem or in hybrid data centers? There's a lot of interactivity. These SaaS applications are hubs with many, many spokes throughout the enterprise coming into them. And just like we see on an operating system, there's users and there's service accounts and there's integration accounts. Then there's privacy and data governance. Where is that data stored and who has access to it? And are you compliant with all the regulatory requirements that you have? And just getting a lens on who has access to your data and are you meeting your compliance obligations is very, very difficult because every SaaS app is going to be configuring compliance and measuring compliance a little bit differently. And then the last piece, third-party integrations, apps, and APIs. What apps are running? What are the users doing with it? Are those apps shipping my data out of the SaaS cloud that I trust across the world to a third-party application I've never heard of before? What APIs do we have configured and listening? Do we have high-privileged APIs listening to the anonymous internet? And now the anonymous internet can start to read and write my data almost like an open S3 bucket. Well, that's not system configuration, and that's not user permissions. So SaaS security management is really looking at the multiple domains of SaaS security and putting them together into a framework that allows security teams to manage multiple security domains at scale.
Excellent. So I will talk us through this next slide, and then I'll turn it back over to Brendan. So really, what are some of the unique SaaS challenges that we have to think about that we sort of alluded to before when we said the architecture is a little different? And I'd say, the first point is that a lot has changed in the SaaS world in the last 15 years ago. For starters, today there's just simply way more SaaS apps than there were 10 years ago, and the number's growing all the time. I remember the CASB providers used to put out data that, the number of SaaS apps in existence was 700, then it went to 800, then over 1,000, 2,000. It's probably now in tens of thousands. But we've also got the other real notable point is that you could argue that SaaS apps aren't necessarily just apps anymore. A lot of them have evolved into actual platforms with their own ecosystems. If you look at Salesforce, if you look at ServiceNow, Workday, et cetera, these are really own ecosystems to yourselves. And in fact, many of them have tons of third-party applications that integrate with them, which adds another thing to look at and something else to worry about that I think Brendan's going to talk about later. We've also seen SaaS apps are now arguably mission critical. Years ago, that wasn't necessarily the case, but firms are using them and basing their business on them. Their most sensitive functions are now run through SaaS apps. They're storing sensitive data. Years ago, I think it's safe to say a lot of firms were worried about putting sensitive data and PII in their SaaS apps, and now that's more common. We've also seen some interesting things with SaaS apps in terms of the numbers of settings and API calls, which can make it really easy to leave sensitive data accidentally exposed, kind of like a SaaS security posture management issue. And we've also seen just the way SaaS apps have evolved over time has just become a lot more complicated. So I guess with that, I'll turn it over to Brendan, and he's going to drill a little bit deeper into some of these challenges and also spend the rest of the talk talking about ways we can go about addressing them and some examples. So Brendan, all over to you.
Hey, thanks so much, Garrett. So I've been doing this for more than 20 years. I've been a security practitioner since the late 90s. Before founding AppOmni, I was security CTO at ServiceNow. Prior to that, I was the CSO at Salesforce. I was at Salesforce for a total of 10 years. So I've really been working on securing SaaS applications full time since 2007. And as part of that, I get asked all the time, how are people actually getting breached? Let's talk about real world risk. So today I'm going to walk through 3 recent and real examples of where we have seen risk and where common pitfalls within SaaS security has led to pretty terrible outcomes. So I'm going to talk about a third-party application breach. I'm going to talk about accidental data exposure through a misconfigured support portal. And then lastly, anonymous API access, how it happens and how it can cause such a big problem. So in the first one, we're going to talk about third-party apps. But to get to that, we need to look at the third-party app landscape today. So AppOmni has worked with hundreds of customers to secure their SaaS platforms. And this is the data that we find. On average, there are 42 third-party applications connected into the average customer SaaS environment. 42 third-party apps either directly running on or integrated through cloud-to-cloud communication into your core SaaS applications. Of that number, 22 haven't been used in 6 months or more. These can be remnants of data migration or digital transformation. They could be apps that users connected, tried for a little while and never came back to. They could be free trials that expired. But these applications continue to run and they continue to have access to your production environment until you turn them off or you remove them. So over half are unused. Then we look at how did these SaaS applications get in there. 20 of that 42, so roughly half of them, were installed without any IT or security oversight. This is end users directly installing applications either through the App Store or connecting via OAuth, and you have these apps in your production environment with part of your user's credentials, and the IT team doesn't even know what these applications are, and the security team has no visibility. This is not the exception. This is the rule. We see it all the time. So what are these applications? Well, they're all different. We ran what are the top 10 applications from 5 of the major app stores, and here's what you find. What you find is the top 10 apps for Salesforce, completely different than the top 10 apps for M365, ServiceNow, Workday, GitHub, and others. So it's not just one application. It's multiple applications, and you'll have a top 10 list within a given app store, but they're all having different purposes, adding value on top of these core platforms, like a Salesforce or a GitHub or a Workday. So let's talk about how authentication for these applications works. I'm going to go through this quickly, but what we need to understand is the basics of SaaS web authentication. There's 3 main ways that you can authenticate: direct username and password, an IDP-initiated single sign-on flow, or a service provider-initiated single sign-on flow. And I'm going to walk through each of those. The first one, standard username and password. I type in my username and password, I click submit. If it's valid, I get a session ID. This is the way web applications work. But let's say I'm using an identity provider. I've got Ping Identity or ADFS or Okta. I've got something in place doing strong authentication. I could have multi-factor authentication, zero trust authentication through my identity provider. But once the user connects to that IDP, the IDP is going to pass a SAML assertion and log that user into the SaaS application. And the result is a session ID back to the user's browser. The third type, which is service provider initiated flow, this is where you can configure your SaaS platform to refuse local authentication. If any user tries to authenticate directly, it's going to redirect them to the IDP and say, if you want to talk to me, first you got to talk to this identity provider and do strong authentication. This is a best practice, but the end result of the user going through this is a session ID. So you always get the session ID, no matter how many hoops you have to jump through for that initial user authentication. Once you have gone through that hurdle, once you're authenticated, your browser is just using a session token. And until you log out or reboot or close your browser, that's all you need for the remainder of the day. So now that I've been authenticated, whether it was simple authentication or very strong zero trust authentication, once I'm authenticated, I'm in the SaaS cloud. And let's say that I'm having challenges with my writing. So I'm going to take a very popular grammar plugin, and I'm going to install it into my office productivity SaaS environment. It's going to help me write better emails. It's going to help me with my documents and the things that I'm writing for work. And I can do that for free, actually, through the App Store. So I'm going to go install this grammar app into my office productivity SaaS platform, and it's going to ask me, hey, Brendan, this app is trying to connect to your office environment. It's asking for read update contacts. It's asking to sync your data. It's asking to read your emails. And I'm going to click yes. Now, it's important to look at when we install these applications and they give us their bill, here's all the privileges that we need or the security access that we need. It's not multiple choice. It's a yes, no. So you can't start pairing those away. You either say yes and the application installs, or you say no and the app doesn't install. So as a user, I don't have much of a choice, but I really want this grammar app. So I'm going to click install. Now that I'm authenticated and I said, yes, I accept this, please install it, an OAuth token is going to be created. And my office productivity SaaS application is going to give one of Brendan's OAuth tokens to the grammar app. This allows it to maintain API-based cloud-to-cloud communication without me ever having to log in. So the next day when I come into the office and I do my single sign-on strong authentication again, I don't have to go re-authenticate that grammar app. It just keeps running in the background because I've already granted it access once. This is not a bug. This is a feature. This is the way applications are meant to talk to each other. Think about the apps that we have on our phone to get email. We don't have to sign into those every day. You have to strongly authenticate it once. And in the background, whether you're at home, whether you're at work, whether you're at the airport, it's syncing your email in the background. These application tokens are valuable and they make it easy for these apps to work, but they also can cause a backdoor to be created. We have seen in breaches like Kaseya, we have seen in breaches like SolarWinds that third-party apps can be the weak link. As an attacker, if I can break into one of these third-party apps, even something like a free grammar app online, that may not be my ultimate goal. I want to get into that application because it has OAuth tokens into the mailboxes and third-party apps and document repositories of all of these various customers. When we think about a classic attacker's kill chain, what they want to do is land, they want to increase their privileges, and they want to move laterally. That's how we tend to see attacks work in the enterprise. This is a new twist on that. You can't really escalate your privileges if you attack one of these third-party apps. The bill of privileges has been set at install time, but you can move laterally instantly. If you can take over one of these applications, it's already got valid, authorized API access into a multiplicity of different customers' production SaaS environments. And attackers know this. So when we look at third-party application breaches, there's certain things that I see people get correct. They look at their identity provider. I'm seeing more and more zero trust and strong authentication. And I'm seeing SecOps monitoring for things like credential spraying or suspicious activity at the identity provider. But what tends to go wrong is there's an incorrect assumption that apps need to behave like users. They need to log in like users, and that everything must go through your identity provider. That's typically not the case. And oftentimes, teams don't have any visibility into what's going on in the SaaS application. How many OAuth tokens has it handed out? Are those tokens being abused? How often are they being refreshed? How often are they expiring? Are we even using them anymore? There's no visibility, and you're not going to get that from your IDP. You have to look at the SaaS application and see what third-party apps are in there and what they're actually doing. You need an inventory, and you need monitoring of what those apps and APIs are doing in production. I'm going to talk about a second case, and we have seen this so many times over the past couple of years. Most SaaS applications have a built-in application web server functionality, and this is not tied to one particular platform. We see it typically where teams want to expose part of their data to their customers or part of their application. And we're going to go through a recent breach around a customer support portal where there was a back-end SaaS application exposed via web so that the knowledge base and FAQs and support portal could be online for customers. And an attacker found it and abused it. It's a pretty simple attack when you think about it. When you connect to a support portal, here we have a classic support portal that's very basic. It says, how can we help? You can search for your problem. You've got different requests. You can open cases. You can look at the knowledge base. You can ask the community for help. But underneath the hood of this support portal is a SaaS application. And the database behind this, the SaaS database, has the support case table. And so this was configured to give two classes of users access to cases. All of our internal users are support agents. So we're going to give them full privileges to support the support case database. They can read, write, create, delete cases. And then we're going to take the outside users. This is our customer. This is our external support user. And we're going to give that support user profile access to read, write, and create new cases. So we're granting these two different user identities database table access in the SaaS platform. This is important. So now when we go back to our SaaS application, and I see this support portal, there's something interesting here. It says my open incidents, and these are the most recent support tickets I have. So what I'm going to do is I'm just going to inspect this element in my browser. I'm going to dig into the HTML and see what that widget is doing. And behind the scene, there's a little bit of JavaScript. This is a very basic JavaScript query. It's hitting the case API, and it's passing an ID parameter, in this case 100682. And that is one of my support cases. And based on the response from that query, it's populating that little incident widget with JavaScript. So what we did here, and what the attacker did, they went through and started incrementing the ID parameter in the query string. So our case was 100682. The attacker just went 683, 684, 685, and started requesting the next cases, and they found out that they could get responses. So they were getting responses to other people's cases. But there was something else that was very interesting in that response, which was a new parameter we'd never seen before. You can see it there highlighted. There's a parameter called portal user ID, and that is 502345. So using the exact same method, we're going to now request a user instead of a case, and we're going to request user 2345, 2346, 2347, and so on. And it turns out the application will spit all that data back. So we have users that all have the same privilege level in the SaaS application, which means any user of this support portal can see any data belonging to another user. So what the outside world should have seen was just their cases, just their support portal, just the tickets that you've logged and the data that belongs to you. But because this was a window into a huge multi-tenant SaaS application, this is what the outside world did see. This is actually a screenshot of us responding to the issue with this customer. So I've blacked some things out here, but this is a real showing. There's a lot of stuff that the outside world should have seen, like patches and release notes and news articles and FAQs and how-tos. And there's a lot of information that was PII that was exposed. Attachments, email messages, user data, some stuff that's sensitive enough that we actually blacked it out. So what you had was a big mismatch between what people saw on the screen and what the underlying permissions to the SaaS database allowed. I see this all the time where you have users in the line of business that are point and click configuring whole web and application servers, and they confuse authorization and data access with UI visibility. So in this case, you had a small portion of the SaaS application exposed through the support portal. And that wasn't bad. It can be locked down. And a dedicated role was created for these external people to support user entitlement. But what went wrong was people confused this UI visibility with data security. And with a very simple attack, doing a little bit of JavaScript and incrementing integers on that API query, you were able to dump huge amounts of data. And that's because there was no security management process. The security team had no visibility that these features and functionality were even available, let alone that people in the business were standing up whole full-featured web and application servers connected to their SaaS platform and publishing them on the internet. And then lastly, I'm going to talk about anonymous API access, because this is another one that we see so often, and customers are accidentally exposing their data to the public world. How does anonymous API access? Who would ever leave anonymous access open on the internet? Well, it may surprise you how common this is. So I'm going to walk you through an event that happened not that long ago, and I'm going to use AppOmni as an example. So this, of course, didn't happen to us, but we're not going to name the person that was actually breached. So let's say that I'm hosting a wine event, and I'm going to set up a RSVP form, and I'm going to use a SaaS application to host that. So I have this marketing web form, and it's connected to a third-party application, my company CRM, on the back end. So this marketing SaaS application is allowing me to quickly and easily publish a form that says RSVP to my virtual wine tasting. The only pieces of data that I need are your email address, your name, your phone number, and your shipping address, so we can send you a bottle of wine. Now, the way this was set up, it was set up to take some very basic information through a post request and hand it to the CRM. Now, you don't want users to have to go create an email address and create an account just to RSVP to your web form. So no login was necessary for this web form. Anyone in the world could come to the web form and type in their data. The SaaS application would then take that post request and hand it to the backend CRM. This is like a mailbox. Anyone on the street can drop something into one of those blue post boxes, but it's locked. No one can retrieve it once it's been put in there. So this is an anonymous, one-way write architecture. Anyone can sign up. That registration is handed to the CRM application on the back end, and there's no read access coming back. So that's actually a very secure architecture. It's a one-way transaction, but it created a functional problem for this company. The functional problem was people were signing up multiple times, duplicate leads, people were getting multiple bottles of wine shipped to them, or in some cases, account reps or customer service managers were having their customers paired with the wrong people. And the business wanted to fix that. They wanted to say, don't be double signing up or triple signing up customers. Don't be sending customers to the wrong group. Go look and see if they already have a support rep or a sales rep that they're working with, and make sure that they're with them. Very, very basic functional problems that they're trying to solve here. And this is how they solved it. They gave this SaaS application read access to the CRM database. So instead of just dropping that letter anonymously in the post box, now we can suddenly read through the post box to see if there's already a letter inside. So now this anonymous one-way write has become anonymous write has become anonymous read write, where anyone can post to the form, but given the right privileges or the right query, they can extract things back. So they created a data leak here by changing the permissions of one single account from write only to read write. And I'm going to walk you through what that attack looks like. Very similar to what we did before, all we have to do is inspect element in Chrome or open up the HTML source and start looking at the page. When I sign up for this marketing web form, it's a simple post request and it's sending it to a particular API. Well, I can now hit that API and query based on email. Previously, any read operations I tried failed. There was no read access. It was write only. Now that the read functionality has been turned on, that entire API has woken up. It was always there. It just had nothing connected to it. Now that it's got that backend CRM connected to it for the read operation, all of the data is at its fingertips. So now when I search based on email address, I get a lot of information dumped back that I shouldn't see. And in doing this, we suddenly learn a new parameter, just like we did in our previous attack. It's leaking data and teaching us more about the SaaS application by us simply querying for user emails. It's passing back this new parameter called company ID. And so we can see that there's a distinct company ID, and let's query it and see what data we get back. And when we query that company ID, exactly what we expected came back. It gives us data on all the users associated with that company. So suddenly, I don't need to guess email addresses anymore. I can just iterate through company IDs by incrementing that integer in dumping contact details and account information out of a private CRM that's on the back end, not even connected to the internet, for all of these systems, because my SaaS application for my virtual wine event was overly permissioned in how it's signing up. So what was set up correctly here was having a dedicated service account and having that one-way write architecture. That is secure. That's a great way to build this. But what went wrong is you had two different systems, and there was one privilege that made it secure, that lack of a read operation. And by granting that read access to your marketing SaaS, the whole architecture went from secure to completely insecure. And to make the matters worse, no one was monitoring that key security control. That write-only access was the linchpin that made the whole thing secure, and no one was monitoring if that changed. And so it did change, and it changed to solve a functional problem, and it created an enormous security problem. And these are not changes being made by security people. These are people in the line of business. This is your marketing team. This is your sales team. This is your sales ops administrator or your IT database admin. It's not necessarily security savvy people, and it's not necessarily people that understand that there's security impact to the changes they're doing. They're just trying to host a virtual wine tasting. They're not trying to be an insider threat. So takeaways and best practices for what we see. What should security teams be doing to better secure their SaaS platforms? I think that there's a lot, but we had to come up with just a few of them here. So the number one thing that I have to say is embrace the SaaS shared responsibility model. SaaS is not magic. There isn't one security button, and as long as you press the security button, all the shields are up. It doesn't quite work that way. It's harder, and you need to understand what your responsibilities are and what your people in the line of business are doing in these applications. Number two, you need to define who owns SaaS security. Is it the IT team? Is it the line of business team that manages the application? Is it security? Is it a shared responsibility? But there needs to be ownership. What I typically see when we're responding to breaches, who owns SaaS security is a big game of not it. Everyone's pointing. Security points at IT points at the business points at security. It's nobody's fault, but no one was accountable, no one owned it, and now we have a data breach on our hands. Number three, recognize the limited scope of tools like CASB. There are a lot of network problems. There are a lot of reasons that you should have strong network security, but trying to firewall your SaaS is not the right approach. If your SaaS gets email, if it responds to text messages, if it has a web portal, if there are any external interfaces, you can't firewall it off from the internet. SaaS security, think of it more like securing a web server. Portions of it are meant to be on the internet. Is it properly locked down? SaaS is an application and data problem, not necessarily a network problem. And then lastly, take a proactive approach. Don't wait for a breach. And unfortunately, there's a lot of breaches that I think are being discovered and will continue to be discovered because so few people have visibility into what's going on in their production SaaS clouds. But who does have visibility is the attackers. We have seen APTs and state-affiliated hacking crews go after major SaaS platforms successfully in the past. And we have seen that sophisticated actors and criminal gangs are very good at mapping out enterprise attack surface and understanding where security teams don't have visibility. And very few security teams right now have proper visibility into what's going on in their production SaaS applications on a daily basis. So protecting your SaaS data, secure your data, not just the perimeter, as I said, gain visibility into who has access to your data, implement guardrails for your users. You can't gate every single change. People are living in SaaS applications all day, every day. So you need to understand that a gate-based approach is either going to slow down your business or it's going to completely miss things. But having guardrails in place to make sure that your users aren't shooting themselves in the foot is the best way to enable the business to move quickly and securely without sacrificing data privacy or security. And then lastly, you need to continuously monitor your SaaS environment. This is not a once a year, once a quarter pen test. This is an all day, everyday problem. Now more than ever, people live inside SaaS applications and they're making changes all day, every day. So monitor your SaaS applications frequently and on a daily basis. Think of them like endpoints. Think of them like operating systems. You wouldn't monitor your endpoints once a year or once a quarter. You have something always watching, always monitoring. The same is needed with SaaS. And with that, I think we're going to open it up to questions. Or Garrett, if you have any final thoughts that you would like to chime in on, would love your feedback.
The old mute button got me. Yeah, this is really helpful. I think to your point, I mean, if anything I could drive home is that, if I haven't already, is that the people are starting to finally, I think, come to grips with the fact that SaaS security has got its own unique problems and its own unique challenges, and it's a completely different beast to work with. But I think we're finally making some headway. So look forward to seeing what kind of questions we have.
Great. So, Brendan, we do have some questions that came in. The first one is related to your customer support portal example. And an audience member says, so how does an organization protect themselves from this scenario since the organization doesn't have full visibility into what the customer support portal is running on? What is outlined in a SOC 2 report may not be operating effectively, and or the controls in a SOC 2 report doesn't describe everything.
That's a really good question. That's an advanced question. So whoever asked that question, thank you. Compliance and security are two different things. They really are. Compliance should be a byproduct of security, but just because you have a SOC 2 report doesn't mean that you're doing things securely. I like to think of it as, if you built a bad house, you don't blame the person that sells you the lumber, you blame the builder. So SaaS platforms have all of these applications. They have built-in web servers, app servers, very robust capabilities. And it's usually off and secure by default. Your users have to go in and turn it on. So this is IT development. The fact that they're using clicks more than code doesn't mean it's not IT dev. You can set up and stand up a web server nowadays with just some clicks and using a simple web editor and put a web page on the internet. Well, these SaaS applications have done that and even more. They make it very, very simple. So you need to go look in the SaaS applications, the ones that have all your business data, all of your customer data, and look at what are our external entry points? Do we have web servers running? What APIs do we have exposed? It's not something necessarily the cloud provider is going to be able to tell you because it's the configuration. It's the cloud provider owns the apartment building. They're not looking inside each individual tenant's apartment. And this is a very personal question. How have you set up your data? Who have you given access to? What third-party apps and integrations have you connected in and have running on it? So I think the way to go in there is start with mapping your attack surface within the SaaS application. Look at those APIs. Look at the various privilege levels. Identify what external users do we have that we're intentionally letting in. And then I'll give you the vendor answer. The quick one is if you really want to know, you can just call us. We can give you a quick scan in less than an hour. We'd be happy to show you who has access and all of that. But this is not something you necessarily need us for. You can go dig into the config, talk to your team, and start to map that attack surface yourself.
Great. Thank you, Brendan. Here's another question from the audience. Thanks for these examples. They're very helpful. Are there any other SaaS issues that companies should address right away?
Yeah, many. Like I said, it's a personal issue. There isn't a security button, and you just got to find it and turn it on, and then all of a sudden everything's secure. It comes down to intention versus implementation. What did you intend to do, and what did you actually do? So you need to look at the business intention behind these apps. Do you want to be receiving automatic emails? Okay, well, then you have a worker that's connected to the email system or receiving email from the public internet. You need to look at that just like you would look at an Exchange server or other type of MTA. Do you have a web portal? Okay, well, lock it down like a web server. There's code issues to think about, but there's also what privilege level does it run as? We see sites getting connected running as domain admin or system. You would never do that on a Windows or Linux server, but somehow in SaaS, the business is doing it and no one's paying attention. Do we have the same best practices that we would apply on-prem? Do we have dedicated service accounts? Are they low privileged? Are they locked down using the principle of least privilege to just the data that they need? And then, of course, third-party apps. Look at what vendors your users have let into your environment, who have authorized persistent access across the internet into your environment. Understand who those vendors are and put a third-party application review and governance program in place. Sometimes you can prevent your users from being able to install these things directly, but that's configuration and user permissions. And then there's also the case of anytime someone attempts to or successfully installs an app into your SaaS environment, do you get an alert? Do you have an approved list? Think of it like on an endpoint. We have application whitelisting, and we have ways to query our endpoints to make sure malicious apps or apps we don't want are not running and being installed by our users. This is the exact same problem. It's just a different flavor.
Great, thank you. And I know we're nearing the top of the hour, so this is our last question. I think this one will be great for Garrett. Why do you think SaaS security has lagged other forms of cloud security?
Great question. So I think a lot of it goes down to, as I mentioned earlier, the shared security model, right? And how so little is available to the customer, right? I mean, how much of it is actually controlled by the SaaS provider and how little of that stack we actually get to see or touch, right? That's part of it. I think the other part of it is on the API side, right? Let me back up a bit. I mean, part of that is in turn that's dictated certain types of architectures. If we go back to CASB, right? One of the problems with CASB years ago was most of them started out with a proxy-based architecture, right? Either a forward or reverse proxy, which meant that you essentially had to route all your traffic through the proxy to get whatever protection they were offering, whether it was encryption or DLP scanning or what have you. A lot of these proxies, in order to work, they would have to essentially reverse engineer the SaaS app. And SaaS apps update all the time. So a lot of times what would happen every time the SaaS app updated, the function wouldn't work or it would break the SaaS app. The other issue is, with users being distributed everywhere and using multiple devices and what have you, it wasn't always feasible, I think, to route all your traffic through the proxy, right? A lot of times people would go direct from a mobile device right to a SaaS app with completely bypass the proxy. So there are a number of issues, and I think eventually that architecture started to give way to APIs. But part of the challenge with APIs is, as I'm sure Brendan knows well, is they're all different, right? They're architected differently. They expose different types of data. They're updated more or less frequently. So I think a lot of it has to do with just some of the architectural limitations. But I think it's also the market space has evolved, right? We have a better idea of understanding what's more of a concern now. We addressed some of that today too. Some of the newer issues, third-party apps, I think is a really big one that nobody's really paying much attention to these days, which I think opens up a whole new can of worms. So, I think overall it's a non-trivial technical challenge, and I'm sure that Brendan and all the AppOmni folks are well aware of that. It's not a simple thing to solve.
Yeah, it turns out security is really hard. We try and make it easy, but security is hard.
Right? Who'd have thunk it?
Great. Well, thank you so much, Brendan. Thank you, Garrett. This was a fantastic conversation, and I'll turn it over to Julieta to end the webinar.
Thank you very much to all of our speakers, and thank you all for attending. On behalf of 451 Research and AppOmni, I want to thank you for joining today. And don't forget, the on-demand version will be uploaded shortly.